Welcome to Swift Programming. I assume that you are an iOS developer. Certainly you know Objective-C and want to get a quick start on Apple's new programming language. So let us begin. As the tradition goes, we begin with Hello World program. This slide shows the full code listing for our Hello World program. Surprised? No headers, no main, just a single statement. Yes, this indeed is a complete Swift program that will print Hello World on your console. I am not going to run a demo on how to run Hello World program in Xcode. The new Xcode provides Playground where you can type in your Swift code and see its effect immediately on an adjacent panel. I leave it up to you to experiment with it. While taking this course, you may not be required to use Xcode to practice the code presented in various lessons. I have taken efforts to explain the code syntax thoroughly and hardly you will need actual hands-on for learning. So let us begin with a few fundamentals. Like any other language, you need variables to store the values used in your program code. Constants are like variables whose values cannot be changed. Swift extensively uses constants to make code safer and clearer in intent. You will understand the use of constants better as we go through a few coding examples. In Swift you use constants more often than in other languages such as C, C++. Tuples are not found in Objective-C, though the concept exists in other programming languages. Tuples group a set of values that can be passed around in your code. You may send a tuple as a parameter to a function and also return a tuple as a return value of a function. This enables you to return multiple values from a function as a single unit. Isn't this great? I will explain you tuples further in details as we progress ahead. Optionals is a new type introduced in Swift. This may be compared to a nil value for a pointer in Objective-C. In Swift, optionals work on any data type and not just classes as in the case of Objective-C. Optionals just say that there is an associated value that equals some x or there isn't a value at all. More on this later. Swift is a type-safe language. Like most other languages, there is no implicit upcasting. If the code expects a double, you must pass a double. Passing an int and expecting that it would upcast to a double is wrong and will generate a compile time error. Having seen some basics of Swift, you will now continue your study by going in depth of the 4 types you studied so far. You declare variables with the keyword var. Here we declare a variable called angle. Note that the data type for angle is not declared anywhere in the program statement. We assign a value of 32 angle. The compiler uses this information to and for the constant's data type. As the assigned value is of type int, the variable angle now assumes a data type of int. You cannot now assign any other data type to the variable angle. This assignment is invalid. Let us now look at a few more declarations to understand how the variables' types are inferred from their initial assignments. The variable epsilon is inferred to be of type double. The variable daily temperature is also of type double, as the literal constant on the right-hand side of the expression is doubled by default. To declare a variable of type float, specify its type explicitly. Today's temperature is of type string. You need not initialize the variable at the time of its declaration. In this case, you must specify its type in the declaration statement. Later on, when you assign a value to it, the runtime ensures that you assign a value of the same data type or else the runtime error occurs. To declare multiple variables in a single statement, use comma separator. You may declare variables of different types in a single statement like this. You declare a constant with the keyword let. Like variables, you do not have to specify the data type. The compiler infers it from the assignment. you must assign a value at the time of declaration of a constant, otherwise, a compile time error occurs. You are allowed to use any Unicode characters to name your variables and constants. In this example, we used pi symbol as the name of the constant. A name cannot begin with a numeric digit. Likewise, it cannot contain mathematical symbols, line and box drawing characters, etc. One interesting case here is that you may declare a variable or a constant with the name same as the reserved keyword. Look at this example. The code declares a variable called float. To use a keyword as a name, you must surround it with backticks. Here, the variable float is assigned an initial value of 3.4. The next statement changes this to 5. The third statement prints a message on the console giving the last assigned value to float variable. The global string function converts its input into a string value and appends it to the string on the left side of the plus operator. I will now describe various data types defined in Swift. Swift defines 4 classes, each for declaring signed and unsigned integers. Additionally, it provides int and uint classes. Depending on your platform, they represent either a 32 or a 64-bit integer type. Double is a 64-bit floating point number and float represents a 32-bit number. Bool represents a boolean, with 2 predefined constants true and false. This slide shows the various ways a numeric literal can be declared, assigning values using different numbering systems. Note that the value assigned to the variable called hex exponent is 15 multiplied by 2 raised to 2, that is 60. The literal 2,000,000 uses underscore character to make the constant easily readable. Swift is a type-safe language. Consider 2 declarations shown here, one is of type int16 and another is of type int32. Suppose you want to add these 2 variables. This statement generates a compile time error as the 2 operands to the add operator are of different types and Swift does not provide an implicit upcast of the data type. Adding a typecast to either operand removes the compilation error. Now, I shall explain tuples. When you want to pass around multiple values in your code, tuples come to your rescue. You group multiple values of same or differing types into a single unit and pass it around. This is an example of a typical tuple. Here 4x is a tuple which gives the conversion factor from default US dollar currency to euros. The type of currency to convert to is specified as first element of the tuple and the second element specifies the conversion factor. Once created, you can change its contents anytime in your program code. This statement now sets the conversion factor for pounds. In this code, we create a tuple called event. It contains 2 elements, both are of string type. The first element is given the name time and the second one is called name. These names will be used later in the code to access the individual elements of the tuple. Here we access the values of the 2 elements using their assigned names and print those on the console. Now, we change the tuple to set the new event. Tuples values can be changed any number of times like this. We now print the current value of tuple event on the console. Note that, rather than using the explicit names for its elements, I have used the indexing to refer to an individual element of the tuple. We now proceed to optionals. I have said this earlier, an optional either has a value or none at all. I will describe this with an example. This line gives the signature of toInt function of string class. Do not worry even if you do not understand the complete syntax here. We will be discussing functions later in the course. It is enough to know that the function return type is specified as int followed by a question mark. This exactly is an optional. The function may return an integer if it is able to convert the input string into a valid integer value, or it does not return anything at all. Another typical usage for optional comes in when you accept the customer address in a web form. Generally, the second line of address is optional. You may declare a variable for storing address line 2 as shown here. Note that the variable is of type string. We append a question mark to the data type to indicate that this variable is optional and may not thus contain any value at all. The code now assigns some value to address line 2 variable. We print this value in the next statement. To extract the contents of address line 2 variable, we append it with an exclamation mark. This is called unwrapping. What happens if we eliminate this line totally? The address line 2 variable is assigned a default value of nil at the time of its declaration. When you try to print its value on the next line, a runtime error will be generated. You can check for a non-nil value as shown here before trying to unwrap it. The if condition ensures that the variable address line 2 has a valid value before it is used in the further code. You can check for a non-nil value as shown here before trying to unwrap it in the next statement. At times, you may be sure that the optional will have some assigned value before it is used elsewhere in the code. Take the case of address line 1. This is a mandatory field on your form. You will declare an optional for storing this field by appending an exclamation mark rather than a question mark. Later on, when you print the value of this variable, you need not unwrap it. At some point later in the code, if you assign an explicit nil value to it and try to use its value somewhere in the code, you will receive a runtime error. Before I conclude this lesson, I will describe how to add comments to your program code. Like other languages, Swift supports both single-line and multi-line comments as illustrated here. Besides these, Swift supports nested comments as shown here. This enables you to comment out large blocks of code quickly and easily. Let me summarize what we have covered so far. You learn the semantics of variables and constants. You learn tuples that do not exist in Objective-C. You also learned optionals, which is a new introduction in Swift. You can now proceed with the next lesson on operators. Hope you like this module. Over the past several years of iOS development, we have deployed many apps in the App Store. Like this course, many of these apps are free to download. Do visit the URL mentioned here to download and try out these apps. Thank you for supporting our development. Now, as you have completed this module, you will definitely like to look up other modules in this course. Do visit the above URL to get links to all other modules in this course.